Okay, today I'm going to give you the answers for the questions on the homework. Question 1 asks us to write the definition of continuity. Continuity is where we don't pick our pen off the page, and the mathematical definition is the limit from the left equals the limit from the right equals the value for all points you want to define continuity on, whether it's 1 point or a group of points. Now let's see if I did the next part right. The next part asks for the definition of the derivative. And the definition of the derivative looks similar to this, but I think I'm missing something. What do you think I'm missing? Well, derivative means differentiable. Derivative means derivative. Hey, I need these symbols in there. So that the limit of the derivative from the left equals the limit from the derivative from the right equals the value of the derivative. Remember, if something is differentiable, or something you take the derivative of, then it is continuous. So once again, if something is differentiable, then it is also continuous. And if something is not continuous, then it is not differentiable. Taking a look at the next question, it said find y if y prime was 12x to the negative third. I'm not exactly sure what it's going to be, but I know it's going to go up 1 power. It's going to be, and up from negative 3 is negative 2. And I know the answer is going to be 12 over negative 2, or the answer is going to be negative 6x to the negative 2. And I can check by taking the derivative of that and seeing what I get out of that. Well, the derivative of negative 6x to the negative 2 is going to be equal to negative 2 times negative 6x to the negative 3, which is going to be 12x to the negative 3. The trick is just to take this power, go up 1 unit, and then put that on the bottom of the number outside. This is a terminology which doesn't come up that much. This is actually saying the derivative of the cosine of x. Derivative of cosine of x is negative sine of x, because as we know, derivatives of negative values, derivatives of cofunctions will be negative. So the next function gives us y equals tangent x, and they ask us for the derivative of tangent x. Where the heck is that question? There it is. Derivative of tangent x and the derivative of tangent x is equal to tangent x secant x. Right? No, very good, because we know we've got to see a tangent and 2 secants. So the derivative of tangent x is just secant squared x. Next function says find the derivative of the inverse secant of x. I'm doing inverse secant, so that is going to be equal to, secant is 6 ticks and you're dead, so it's 1 over the absolute value of x times the square root of x squared minus 1. Okay, taking a look at question Q7, it says find the second derivative of 2. In order to do that, we have to find the derivatives first and then plug 2 into the equation. So the first derivative is 4x cubed. The second derivative is 12x squared. So the second derivative of 2 is equal to 12 times 2 squared, which equals 12 times 4. 12 is 24, is 48. That's the correct answer there. Okay, taking a look at the next one, it says find dy dx when y equals x to the third plus 1 to the fifth. We could expand that out if we want and solve it individually, but we can just do the chain rule. To the fifth is 5 to the fourth times the derivative of the inside, which is 3x squared. Q9 says estimate the definite integral from negative 2 to 2. The definite integral is just the area under the curve, so I kind of read through the picture here. Between negative 2 and 2, I'm just going to count boxes, and it looks like I have 1, 2, 3, 4, just about 5 boxes. Really close to that. I'd say about 4.8 approximate. Any approximation in there is going to work out okay. Let's divide them up and see what we get from there. Okay, the homework questions all ask us to state whether functions were continuous, differentiable, both, or neither at x equals c. But instead of going through problems one at a time, I like to take care of problems in terms of groups. Let's find ones that are not, remember, if it's not continuous, it's not differentiable. So let's look for ones that are not continuous at C. This one is not, so it is neither. Let's write that in orange. We don't want to write that in red. Neither. N-E-I-T-H-E-R. That's how you spell neither, right? This one, not continuous, so it is also neither. I always write N-E-I, period. And that works for me. The next one, this one is continuous at C. This one is not continuous at C. Neither. Neither continuous nor differentiable. Neither is this next one. Neither. Neither continuous nor differentiable. Oh, the next one right here is a trick question. We're not looking at the whirlpool down to nowhere. We're looking at C. At C it is continuous, so we're going to skip that one for now. The next one is neither, because it has discontinuity at C. And the next one is neither, because it has discontinuity at C. You'll see I've marked neither on all the ones where it is not continuous at C. I'll mark them in red. Oh, that's not red. I'll mark them in orange at the locations where they are not continuous. Then peek at the next page. See if I have any more discontinuities. I have an NEI here. And the other ones are all continuous. Are all the other functions continuous at C? Yes, they are. Okay. So now I've got to determine whether they're continuous or continuous and differentiable. So continuous or both. And so what I'm going to do is I'm going to look for the ones that are just continuous, and we know those are going to be cusps or corners at C. Cusp or corner at C, this is just continuous. Look for another cusp or corner at C. This one has a cusp or corner, but it's not at C. So I'm going to skip over that one. Why did I leave it? Oh, yeah, there we go. Let's go to the next page. Let's look. Cusp or corner at C. Yep, it's just continuous. Anything that is a smooth curve will be continuous and differentiable at C. So we'll take a look. This one is going to be both. This one is also going to be both because we're looking at the value C. Let's come to here. And the last one is smooth, so it's going to be both. So remember, if it's a smooth continuous curve, it's both. If it's a cusp at that value, it's just continuous. And if there's a hole at that value, or an asymptote, then it is neither. Onward ho, we're asked to graph some functions here. And there's many right answers. It asked me to graph a function that's differentiable and continuous at 3, 5. I will not be drawing arrowheads on here. There's too much work on this graph. I'm going to go to the point 3. I'm going to go to the point 5. It's going to be differentiable and continuous here, means it passes through that point. Could look like so. Could be any such thing. You don't have to have the point there as long as it's continuous there. We are good to go. This one says it has a finite limit as x approaches 6, but it is not continuous because f of 6 is undefined. F at 6 is undefined. It means at 6 it has a finite limit, so the limit from the left has to equal the limit from the right. But when they get there, there's no value. That graph will suffice for that one. It has to be heading to the same point because it says it has a limit. This one says it has a value for f equals -5, but it has no limit. If it has no limit, then the limit from the left of at -5, that means that the limit from the left does not equal the limit from the right. One can be filled in, one can be a circle. Bloop, bloop, bloop. And the last one says it is continuous at 4, 7, but not differentiable. There's only one kind of point that does that. At 4, 7 is continuous but not differentiable. It has to be a cusp. Or a corner, but a corner is a cusp. And those are the problems for homework. In a minute we're going to look at the solution for one of our limit questions.